Good evening, everyone. In this video, we are going to work out one of the atomic structure question extracted from 2012 past paper. This is a science paper 3, 2012. This is the question that we are going to work out together. The question reads, the diagram below represents electronic arrangement of a particular atom. Study this diagram and answer the questions that follow. So here is the diagram. This diagram shows the structure of a particular atom or structure of an atom. So we are taught to study this and answer these questions that are below the diagram. So now question A reads, the relative atomic mass of an atom, of the atom is 23. So here they've given us the atomic mass of this particular atom. And its atomic mass, we are told it is 23. Now, A1, what is its proton number? So, colleagues here, you need to understand the question carefully. What is its proton number? So in this case, they are not asking you to give a definition of proton number. Here what they need is the actual number of protons in this particular atom. That is what they want. So now how do we get to know the number of protons of this particular atom which we have here? So now one key point that you should remember is that they say atomic number is equal to the number of protons is equal to the number of electrons. So it means that if you have the atomic number of an atom, then you know the number of protons. Then you also know the number of electrons, because the atomic number equals the number of protons. The same protons equals the number of electrons. So this is the principle that we are going to use here, where we say atomic number will be equal to number of protons in red, which will be equal to the number of electrons in blue. So now this atomic structure that we have, there's a dot part which is inside there. That one, it is the nucleus. That is where the neutrons and the electrons are located. But outside here, where there are these rings, 3 rings, where there are even those X's, these rings, these are shells. And what we can find on shells, it is the electrons. So what we have there, it is the number of electrons. So now, meaning, if we get to know the number of electrons of this particular atom, then we know the proton number. Because I think proton number equals the number of electrons. So what we have here, these are not protons. Protons are found inside the nucleus. So these are electrons. So we are going to count the number of electrons. So the number of these electrons will be equal to the number of protons. So let's count together. Inside there, we have 2 electrons. Then the second shell that follows, we have 8 electrons. And the last shell, the outer shell, is called the outer shell. That is, we have 1 electrons. So in total, we have 11 electrons. And that is the answer there in red. Okay? Let's go to A2. A2. What is its neutron number? They want the neutron number. Not necessarily a definition, but the actual number of neutrons in this particular atom. That is what they want. So how do we get another neutrons? So here also, you should be remembering the concept of atomic structure. So now here we are going to remember a concept that states that just a definition of a mass number. How do we define a mass number? So now we define a mass number as the sum of protons and the neutrons. So now here it is always important to know what you already have and what you do not have. So in this case, when you look at this question clearly, we have the atomic mass. We also have the proton number. So, and the definition of mass number, it says when you add the protons and neutrons, you definitely get mass number. By the way, don't forget or don't be confused. Atomic mass is just the same as mass number. This is different from atomic number. Atomic mass is different from atomic number. So here, this atomic number, atomic mass that we are given, this is the mass number. Okay, so this is what we are going to use now. Mass number is equal to the number of protons plus number of neutrons. Meaning when we add these protons and the neutrons, we'll have the 23 there. Because 23 is the mass number. That is the atomic mass. Okay, so now, having known our formula now, we are going to substitute. Where there's mass number, we'll substitute 23. Because it is given. It is there. Where there's number of neutrons, we are going to substitute the protons. We are going to substitute protons, the number of protons there, because that is the first question that we calculated. So where there's number of neutrons, there we are not going to substitute anything because that is what we are trying to find. We don't know it. Okay, now let's substitute. This is what we have here. Mass number, it is in green. So it is substituted by 23 also in green color like that. Okay. Then when you look at is equal to, the equal to still remains the same. Then where there's a number of protons, we substitute 11 in red color plus number of neutrons in blue color. There we've maintained because there we do not know the number of neutrons. That is what we are trying to find. From here now, this is a common equation. We are going to collect the like terms as usual. When you collect the like terms, the 11 will go the other side, of course. So we're going to have number of neutrons is equal to 23 minus 11. And when you perform some calculations there, definitely you'll find 12. So the number of neutrons of this particular atom here, it is 12. Then you write the answer there in blue color, 12. Well, we go to B. B1. B, there are two questions there. So we have B1. In which group of the periodic table is the element found? In which group of the periodic table is the element found? Here, you don't even waste time to use a periodic table, ladies and gentlemen. Here, it is straightforward. I'll start with the reason here, explaining you in B2 so that you understand it clearly. Here, explain your answer in B1. Even when I've not found, I can even start with a reason. The reason is very simple. For you to get to know the group in which this particular atom is, you will just count the number of electrons in the outermost shell. That's the answer there. How many electrons are we seeing there on the last shell there? The outermost shell. It is 1. And if it is 1, that's a group number. It is in group 1. You write group 1 like that. Just the number of electrons, it tells you where that particular atom it is coming from. So it is in group 1. You write like that. Explain your answer. I've just explained the answer there. There is the answer. Number of electrons on the outer shell equals the group number. Okay. Thank you for watching. Wait for some more videos.